Hello everyone, this is Professor Connor. I am making this video because a lot of questions have come through regarding the math today on the lab report that you guys are currently doing for solutions and bases. So I thought I would do this so that it might help you. I can walk you through those two problems that are giving some people some grief. And then hopefully this will help clarify some of the issues that you might be having and will help you do the math. So I'm going to start sharing my screen really quick. And we're going to go through these problems that you guys are somewhat struggling with. The first problem I'm going to do for you, or we're going to go over, is the 39 grams of sucrose in the 355 milliliters of solution. So they're asking you to take that and then make the molarity, or come up with the molarity of that problem, and then the percentage of sucrose in that solution using the weight divided by the volume. So right now, let me just make this a little bit bigger. So right now, what we are doing is first we have to convert the sucrose into moles. And so we're going to take the molecular weight of sucrose, and we have to calculate that by using the periodic table. So here is our sucrose makeup. So it's C12H22O11. So we have to break that down into sucrose parts. And so we're breaking it into carbon, hydrogen, and oxygen. We have to look at the periodic table to find out what the molecular weight is for each one of those, and then multiply it by the number of molecules that we have. So for C, for carbon, we have 12 molecules up here in our equation for sucrose. And if you look on the periodic table, carbon's molecular weight is about 12. So we're going to take 12 carbon molecules and multiply it by its weight, which gives us 144. Hydrogen is 1.009 on the periodic table, so we're going to round it to 1. And we have 22 of them, so we're going to take 1, which is the molecular weight, and multiply it by the number of molecules we have, which is 22, and it gives us 22. Oxygen on the periodic table is 15.999. We're going to round it to 16, and so we have 11 of those in the sucrose solution, or in the molecular makeup of sucrose. And so we have 11 times 16 and 176. Because we're doing weight, we're going to add all of these things together, and we get 342 grams. It usually is Daltons, but we transfer it to grams. And so that is what 1 mole of sucrose is. Now, in our 39 grams of sucrose up there, we obviously do not have a full mole, so we have to figure out what percent we actually have, or how many moles of sucrose we actually have. So we know we have 39 grams. So we're going to take 39 grams and we're going to divide it by what a mole is, which is 342 grams. And if we do that, we get 0.114 moles of sucrose within this solution. So now we have to figure out what the molarity is. So we have our moles, we know what we have in that solution. So we have to take our moles of sucrose and divide it by the amount of the solution that's in liters. And so we have 0.114 moles, and we have up here 355 milliliters. We're going to convert that into liters because moles are moles per liter. And so we convert it to liters, and that becomes 3.355 liters. So we have our moles per liter. We do the math on this, we divide it, and we get 0.3211, or 3.321 moles per liter, and that's our molarity, is 0.321. And this would be the way that we add our units. So one thing to note, that sucrose, if they ask you for your other part of it, so molarity versus osmolarity, osmolarity means that you're just looking at the material, and if it can dissociate, you would take this number and you would multiply it by how much it can dissociate. So let's say we had sodium chloride, you can break down into sodium and chloride. It would be 2 more particles, so we could take 2 times this. However, sucrose does not break down, it doesn't dissociate, and so your osmolarity and your molarity would be the same. All right, so the rest of the question is, what is the percentage of sucrose in the solution? So we're going to take our solution, which is 355 gram solution, or liters technically, and divide it by the 39 grams. and we are going to get about 0.1098 or 10% or 11, close to 11% of sucrose in the solution. The 355 grams is basically within the solution of the sucrose that we started with. So 350 mils, that should say mils of a solution, and 39 grams of solution that we're starting with. So about 10%, 10.98 or 11%. So the second part that we're going to do is number 6. That question asks how you would prepare 500 milliliters of a 0.1 molar solution of sodium phosphate from a stock solution of 2 molar solution of magnesium sulfate. So the equation that we're going to use is the MIVI equals MFVF. And what those mean is M is equivalent to mass, and these mean initial. So M is initial mass, and over here you have final mass. The VI is volume, so volume is the initial volume versus the final volume. So now we have to figure out in our problem which ones are which. So what are we starting with and where are we going? So if we're looking at our question, it says, how would you prepare a 500 ml of 0.1 molar stock or solution from magnesium sulfate? That tells us we're going to prepare that. That's where we're going. And then I underline from, because that's what we're starting with, from a stock solution of 2 molars of magnesium sulfate. And so what I have done is I've given myself a little key. 2 molars is the initial mass of the solution we're talking about. We do not know what we're starting with volume-wise. It doesn't tell us that in the problem. We do know that we want to get a mass final of 0.1 molars, and we have a final volume of 500 milliliters. So now that I know all those, based on how I read the question, I'm going to plug those numbers into my equation. So I have 2 molars, and then there's our unknown. And then over here, our final mass is going to be 0.1 molars. And then the final volume, we want 500 milliliters. So we're going to do the math, and we're going to get this alone. We want to know how much our volume we started with. So we're going to do a little bit of algebra, moving stuff over. So this will cancel each other out. We've got it all by itself. We have what we do to one side, we do to the other. So we put the 2 molars over here. These will actually cancel each other out. And nothing cancels this out, which is good because we need to know our volume, which is probably going to be in milliliters. So now we can do the rest of the math. So we have 0.1 divided by 2, and then that 500 mils at the top. So I'm going to make this as easy as I can. I want to get rid of this, so I'm going to divide it by 2, so that would make it an actual 1. And this 500 milliliters now becomes 250 milliliters. So now we are stuck or left with our initial volume, which is what we wanted, which is equal to 0.1, which is being pulled down from here, 250 milliliters, and now we just multiply those across. And so our initial volume of what we started with was 25 milliliters. So hopefully that actually helps. And it gets you back into a place where you can understand the math a little bit better, and then be able to plug in some of those other numbers as well as you're going through some of the practice pieces or just trying to figure out the math. That takes care of 2 questions on your post lab. Hopefully that was helpful. Again, you guys, if you need help, please feel free to email me. I do my best to try and email within 24 hours. Of course, weekends are weekends. But I do try my best to get back to you as quickly as possible. So if you think of other questions you might have, if I didn't cover something that you were still questioning within those problems, let me know and I will talk to you. We can do a Zoom, we can meet during office hours, but I'm here to help. And I hope that you guys are all staying safe. And with that, I'm going to say have a great night, and let me know if you need anything or you need help.